Hello and welcome. We invite you to sit back and watch as we show you how easy you can use anynode as a connector between Zoom and a provider. Zoom Phone Premise Peering allows you to connect to Zoom Cloud using nothing more than a SIP trunk and anynode. For customers who have to manage the infrastructure like an existing PBX or voice services on premises, this will be their optimal choice. Anynode supports a very broad range of PBXs and versions and also provides rich dial string rewriting functions to fit in any PBX dial plan. For a successful configuration with Zoom Phone Premise Peering, you need the following prerequisites. Configuration steps in your Zoom account. You will find more information on that in our tech note Zoom Phone Premise Peering in our community. A SIP trunk and SIP group with referenced users in Zoom Phone and the required configuration and connection to anynode for the premise peering. A public and reachable IP address and public DNS entry with proper mapping for the anynode server. Take note that the anynode server must be reachable through the public IP network. Check that the FQDN and public DNS entries resolve correctly to the proper IP address. A public trusted certificate is needed for communication between anynode and Zoom Phone Premise Peering. This certificate must be generated by one of Zoom's accepted root certificate authorities. Please note that the certificate needs to have anynode's FQDN in the subject, common name, or subject alternate name fields. Configure appropriate firewall rules for the SIP, TLS, DNS, and media connectivity. At least an anynode installation using the certified anynode version 4.6 or higher. Anynode is pure software, runs on Windows or Linux, and is available as a download in our community for Windows. The installation is done in a typical Windows environment and accomplished in a few minutes. For our Linux friends, we recommend our Anynode Linux repository server. This server is intended to help you install all Anynode packages together with their dependencies fully automatically. Additionally, we offer a super fast and easy deployment with Azure to start right away with Anynode in just minutes without any obstacles. When you search for Anynode on the Azure Marketplace, you will find Anynode, the software SBC as a template and as a VM offering. Let's start to connect Zoom with a provider. Anynode provides a scenario assistant to speed up frequently occurring configuration tasks. We select the appropriate scenario. In this example, we create a relationship between Zoom Phone Premise Peering and a VoIP provider. The Node Interconnection Assistant will save you time. It will do most of the configuration work for you by providing numerous predefined system profiles of VoIP providers, PBXs, and other voice over IP systems. For the Network Controller, select Create New Network Controller. For the Zoom Phone Premise Peering connectivity, the corresponding address needs to be selected. In this example, this is the Ethernet interface that is listening to the public IP address, which is set as trunk group in Zoom. In this dialog, the port values can be assigned. The SIP TLS port is by default set to 5061. The unrestricted UDP TCP port range must be set to the local requirements. There is no NAT configuration required for this environment, so we proceed with Next. The required certificate and the private key will be imported via the import of the certificate and / or private key option. Both certificates have to be imported in single files. You must browse both files and select and import one at a time. If the import and subject validation is fine and nothing is highlighted red, you can proceed with Finish. The certificate and privacy key and certificate chain are imported and used. Ensure that the certificates include the correct information and all the required FQDNs as SANs, subject alternative names. Please note that Zoom only allows TLS connections from SBC devices with a certificate signed by one of the trusted certificate authorities. If everything is set for the certificate and private key dialog, proceed with Next. Next, the certificate chain is properly displayed as anynode provides some default validation certificates. If there are no valid chains available, or some are missed, the corresponding certificate has to be imported via add and the invalid ones should be deleted with the remote button. At the moment, Zoom provides 4 large data centers. Please select the data center from which you have received the access data from Zoom. If your data center is not available, click on Other and add the Zoom proxy servers by hand. The required and selected region for this configuration example is EMEA. This region is resolved to the European data centers for the Zoom premise peering. The anynode wizard will automatically set the recent valid FQDNs which are resolved to the IP addresses. Check the FQDNs for validation. It is possible to change them here with Edit. No incoming or outgoing dial string rewriting is required in this example. A default node name is set which can be modified for your needs. Click Finish to proceed with the next dialog. In the Node Interconnection Assistant, you now get an overview of the completed configuration. We will now continue with the Node VoIP provider and click on Configure. Now the VoIP provider preset can be selected from the list. In this example, the generic Other VoIP provider template is used. The assistant requests the network-related settings used by this node. For the network controller, select Create New Network Controller and set one of the network options with its configurations. In this dialog, port values can be assigned for UDP, TCP, and TLS. Ensure that those port values conform to the network and remote configurations. You may define a UDP and SIP TCP port range that restricts the number of ports used by any node. The port range should be at least 3 times higher than the number of maximum concurrent sessions in this node. NAT traversal allows traffic to reach the specified destination when a device does not have a public IP address. This is usually the case if your provider performs NAT or the external interface of your firewall is connected to a device that has NAT enabled. We do not need the NAT traversal menu item for our example, so we will skip it. SIP interconnection is used to decide how the connection to the provider is to be made. Generally, there are the options Node interconnection via SIP trunking and Node as SIP registration client. The connection to our provider takes place via SIP trunking. The remote SIP domain defines where to reach the remote endpoint for outgoing calls. Our provider has given us a username and password with which we enter here. If required, a SIP proxy server URI can be entered. As none is used here, we proceed with Next. The user part of asserted URI has to be set up with the SIP provider requirements. The complete generated asserted URI string will be updated automatically and shown in the assistance dialog. The network peer list for the provider node is by default enabled for the set SIP domain and proxy, and also for IPs that will be negotiated for RTP/RTCP. Host names or IP addresses can be added or changed as needed. Ensure that everything is reachable through the IP network. With anynode's dial string rewriting ability, different call number formats can be made compatible between differing IP equipment. In our example, we are going to add a +4 calls from the provider. Incoming rewrite rules and outgoing rewrite rules are always to be seen from the point of view of any node. You can also add dial string rewritings later. The default node name is set but can be modified for your needs. Proceed with Next for determining any node's routing behavior between both nodes. For the routing, it is strongly recommended to select Use Direct Routing with Prefix Filter. This option ensures that only calls with the matching dial string information of the SIP provider will be established to VoIP system, the Zoom Phone node. If everything is set, click Finish to exit. Don't forget to finally accept the configuration by clicking on Commit. Click on Routing Domain in the left menu tree. You will notice that the wizard has already created the desired routes here. You can find more information about routing in our tutorial video Basics Dial String Rewriting and Routing. Now we are done with our configuration. Switch to the monitor mode. The dashboard gives us a quick overview of all relevant information. At SIP nodes, the operating status of all configured nodes can be read. If everything is working properly, the status is displayed in green. With a double click on the Zoom node, even more details can be observed. Pay attention to the options packets display. The upper value it received shows that the Zoom Phone server is sending any node options packets. The lower value it sent indicates that any node is sending options packets and receiving a response from Zoom. With a click on Refresh, the values are increment. We are now performing a call test. External phone numbers can now be reached with the Zoom client. Of course, the call in the other direction from the provider to the Zoom client is also possible if the Zoom number is dialed. The Zoom client always dials numbers in E.164 format. This should be supported by the provider. If not, the numbers can be converted as needed using the dial string rewritings. In the active sessions, it can be noted how the call from the provider to Zoom uses the route to Zoom. We have reached the end of this video workshop and thank you for your attention. Have a great day.